One of the great things about using classes for objects is that we can extend those classes into subclasses. Now that word may be new to you, but you've seen this idea in practice every day. Suppose we create an object to represent a black and white television. We can send this TV a lot of messages, like turn on and turn off, raise or lower the volume, or go to a particular channel. We might then want to enhance our basic black and white TV. We want to retain all the variables and methods already defined for the object, but we want to add a few more so we can do more, like showing color images. So we can create a subclass of the black and white TV. It can do everything the basic TV does, but it can also respond to messages dealing with color, like make the image more red or less green. Now, let's extend the color TV and make yet another subclass. This one will allow us to create an HD TV. Of course, this can do everything that the black and white and color TVs can do, but it can do even more, like zooming in or showing a closed caption. This is the idea of subclassing. We take an existing object or class and extend it by adding more capabilities in the form of new variables or methods. We talk about this idea using the word inheritance. For once, this means the same thing in programming as it does in real life. New classes inherit or absorb the properties of their predecessors. So when we start with a black and white TV and create a new subclass for color TVs, we say that the color TV inherits everything from the black and white TV. Following this language, we say that the black and white TV is the parent of the color TV, and the color TV is the child of the black and white TV. Synonyms for parent and child are superclass and subclass. At first glance, these terms may seem to be backwards. After all, shouldn't a superclass be more super or more powerful than a subclass? But the terms don't apply to how super duper the classes are, but merely which one is the parent. So typically, a subclass, because it adds variables and methods to its superclass, is more powerful than the superclass. When we create our HDTV subclass, then here the color TV class is the parent of the HDTV class, which is the child, and the synonyms apply again, where the color TV is the superclass and the HDTV that builds upon it is the subclass. Now this is very nice for organizing things, but where this idea really shines is when we send messages to our objects. Let's name our black and white television class simply TV. Like any class, we'll give it some variables, a constructor, and some methods. Now we'll make a subclass named color TV, and we'll give this a few more variables and a few more methods and its own constructor. If we send the message more red to an instance of color TV, then it simply responds to that by executing the procedure named more red. But what if we send the message turn on to an instance of color TV? There is no turn on in color TV. It literally has nothing in the source file named turn on. There's no procedure, nothing. So color TV receives this message that says turn on and it doesn't know what to do with it. So color TV says, maybe my superclass knows about this. And it hands the message up the line to the TV object that the color TV is built on. Just like someone in an office might pass on a surprising request to his or her supervisor. In this case, TV of course knows what to do and it turns itself on. Conceptually, every instance of a color TV has an instance of a little black and white TV inside of it. Anytime we ask a color TV to do something, it does what it can. And if it doesn't know how, it asks its little embedded TV to give it a try. And this goes right up the chain. If we have an HD TV as a subclass of TV, and we send it the message zoom in, the HDTV does it. If we send it the message more red, the HDTV passes that up the line to the color TV, who handles it. And if we send the HDTV the message turn on, it says, I don't know what to do with that. It hands it to the color TV, who says, I don't know what to do with that. It hands it on to the TV, and that executes the message turn on. So conceptually, inside every HDTV is a color TV, and inside every color TV is a regular TV. The beauty of this is that because of inheritance, if we change any class, we change all the subclasses that extend it. For example, suppose we want to create a new message named mute. This turns off the volume and might be useful when we get a phone call. All we have to do is add the mute message to the basic TV class. Instantly, without our doing a thing, every instance of every TV, including every color TV and every HD TV, inherits that new ability. And every television in our whole project is instantly able to turn off its sound when it gets the message mute. When we turn all of this into practice, things can get kind of complicated. So here, I'm going to just give you the basics of the idea. This way, you can follow along when you see it in other people's code, and you can use these basic ideas in your own projects. To see how all this works in practice, I'll use our familiar car class. Our car has a bunch of familiar methods and a constructor. We have setters to set the instance variables and getters to retrieve them. Using this, we can draw a car. Suppose now we'd like to create an advanced version of a car, and it can do everything that a car can do and more. This new enhanced car will be designed to help us move a friend from one apartment to another. What distinguishes this new car is that it has a roof rack on which we can place a moving box. So by analogy with a moving van, I will call this a moving car. So a moving car is just a car, but it has two new variables, a color for the color of the box and a float for the height of the box. We might now draw things this way. Because we have two new instance variables, we'll write a couple of new setters and getters for those variables. Because this is a new class, we'll need to give it a new constructor as well. The constructor takes all the same arguments as a car, but it also accepts a starting height and color for the moving box on the roof. We'll dig into the mechanics for this in a moment, but I want you to get the general idea. Let's begin by seeing how we'd create a new moving car and send it messages. Well, there's nothing to it. We just call the new constructor and we get back a new object of type moving car. And we can send it any message known to that class, or its superclass, or that class's superclass, and so on. So how do we actually do this? It's very easy. There are only 3 new bits of typing to remember. Here's a simplified version of our car class. We start with the instance variables, and to keep things short, I'll pretend for now that there's only one, the car's color. Then we have the constructor and the methods we're familiar with. To make a subclass named moving car, we start as usual and define a class called moving car, followed by an open and closing curly brace. But here comes our first new bit. We want to tell processing that moving car should inherit from car. That is, moving car is a subclass which extends the abilities of a car. So after naming the class, we add the words extends car. That is the essential connective glue. This tells processing that moving car is a subclass of car, and any message that moving car doesn't handle should be handed up to car. The word extends is a keyword that you'll always use in this situation, and of course it will be followed by the name of the actual superclass, here car. Now we can just make a new class as usual. That's where we'll pick it up in part 2.